guys, welcome everyone again. So as I promised you guys, in this tutorial we will talk about the DC-DC converters, and we will talk about how to control them using a microcontroller. For example, Arduino. We have Arduino here. Okay, so here we have two different DC-DC converters. We have this module here, which is based on XL4015, okay, which is typically a buck converter, okay, which is step down the voltage from 36 volt maximum input, okay. And yeah, if you can see here, we got two 10 turns potentiometer with that you can control the voltage and the current, okay. Here, this is the first one, and the second one is a buck boost, which is step up, step down converter. This guy here is based on the LTC3780 IC. This IC is very powerful, can step up, step down at the same time. So mostly we will focus on this guy in this tutorial. This one is the same like this, but this one I started desolder it and dismantle the circuit. I can reverse engineer it for you guys to understand the whole schematic and the whole construction of the circuit. So when we try to change some components, we know what to do and exactly which one to desolder or to modify. Okay guys, so let's start with this one. We will mainly focus on this LTC, okay, LTC module, LTC3780. So got input, output, and we got three potentiometer, three 10 turns boards here. I already marked them for you guys, and also you can see here they also mark it for us. So the first one from the left, it's marked as a UV or under voltage, current under voltage, or the constant current, constant voltage potentiometers. Okay, so you can see here the construction of this circuit is kind of straightforward. We got the main controller here, then we have four MOSFETs, two for the high end or high side, two for the low side, one big fat inductor in the middle. Okay, then we have the input and output caps for the filtering. And here we have a 5 volt voltage regulator. Then we will know later why we need a 5 volt voltage regulator. Here also we have a protection fuse and got op-amp here. I believe is a dual op-amp. I guess the LM385 is a dual op-amp here. They use it for one of the op-amp, they use it for the under voltage, another one they use it for the current control. Okay guys, so yeah, let's try to hook this one to the power supply, supply some voltage, and we try to measure the output and we see what we can do with it. Okay, let's get started. Okay guys, so the main thing of this video, or this could be a series, I'm not sure if we can make it only like a single video or could be like multiple series, depends on the length of the video. So the main objective again of this series is to replace this potentiometer with the signal from the microcontroller or from external source to control the voltage and the current of the module. Okay, so instead of manually using the screwdriver and keep changing the voltage using the manual method with a screwdriver, we will replace it with the signal from the microcontroller so we can automate the process. So yeah, it will be more easy. And also if let's say you want to do your own bench power supply with the closed loop measurement circuit with all the thing you might need, which is the most important thing, is the set the voltage and the current using a microcontroller signal, which is very important. Okay, so this is what we focus on guys in this tutorial, so let's do it. Okay, so now let's connect this guy to the power supply. Take this aside. So here we have the power supply, so it's positive. So you can see here I already power up the module. I use a 12 volt power supply to power up the module. Let me open the output. So this is the output, so 0.6, I believe it's just a noise. And you can see here there is under voltage detected and there is no output. Okay, the output is 0. So now we need to reduce the under voltage protection potentiometer, so it will be trigger the LTC on. So now I need to reduce this. See, now I'm reducing it. So we should see the LED color gone. Here we go. So you can see here the under voltage or the fault LED gone, and the output now is outputting our voltage. Okay, so now we can control the output from here, whether we go reduce the output or go up, because it's a buck boost converter. You see now I'm inputting about 12 volt and the output can go less or more than 12 volt. You see now it's less, which is buck, acting as a buck circuit. Now it will be acting as a boost. If I go up, you see it's going more than 12 volts, so now it's boosting up the voltage. There we go. So now the first thing I will do is to reverse engineer the under voltage circuit and we'll take it out. I don't want this under voltage because sometimes the input might be high or low, which is very irritating to have under voltage. I will try to take out the under voltage. So now we will try to desolder and take out any components that are not really important or useful for us to make the circuit easy to modify. Okay, so let's start with the under voltage circuit. Well, guys, so at this step, we will try to reverse engineer this board, the LTC board, and also to understand the layout and the schematics of the circuit. Plus, we will take out and desolder all the unneeded components, okay, to make the circuit easier and also to make it make it easier to interface with the MCU with the less components. Okay, so first I will start with the under voltage circuit here. Okay, here I draw the under voltage circuit schematic. Okay, if you can see here, this is the potentiometer where we can saw it last time, and here is the op-amp where we use it to trigger the run pin of the LTC. Okay, so if you see here, we are controlling the run pin. If we go to the data sheet, I find the data sheet for you guys. So the run pin number 8 here, not number 6, because we are using the SSOP package. So the run bit is to control the input, forcing the run to be below than 1.5, causing the ICU shut down the switching regulator circuits. And this pin is accept less than 6 volts. So that makes sense with what we are doing here. So if you see here, this is a differential. So we have at the negative input, we have a voltage divider of 75k, which means with the VCC equal to 5 volts. So it means here we have 2.5 volts at the negative parts. Okay, and also let me close it. And the positive input is controlled by this voltage divider, both here and 36k. Okay, so you can control this up and down to control the run. So it means the reference here, the Vref, okay, is 2.5 volts, or whether it's more than 2.5 volts. So the cutoff, I can say, voltage is 2.5. Yeah. So now we need to take out this circuit. So let me bring the schematic again. sorry, I mean the picture. So you can see here, let me highlight it for you in yellow. So this is pin number 8 is 1, 2, 3, 4, 5, 6, 7, 8. Here we go. This is number 8. Let me zoom in. So let's follow pin number 8. Is go to here, go up, under this 100K resistor, and go all the way here, and under this capacitor, go all the way to this pin. Okay, which is pin number. This is the op amp. Okay, this is the op amp we are using. If you notice here, we are using op amp. Okay, so this one go to the op amp pin number. Let me Control Z. Here we go. So it goes to op amp pin number 7, which is this one. This is the LM385. So if we count, this is, by the way, this is the first pin here. So 1, 2, 3, 4, 5, 6, 7. So this is pin 7. Okay. And also this is the, if you notice here, we have 10K to the ground. We have 10K here to the ground. Okay. This resistor is this. Go to the ground. And what else? Yeah, this resistor go all the way to, or before that, let's see the rest of the circuit. So what we have here, let's check pin number 6, which we should see 2 resistor of 75. So pin number 6 is here. Let me take another color. So we'll be here connected to these two. This is 75, this is 75. One go to the ground, one go to 5 volts. Okay, these two resistors. Now what left for us is this resistor here. This is the potentiometer. If you see here, it should be connected to which pin? Pin number 5. Okay, along to the 36K. So if you see here, this is the 36K. Okay, so this resistor is connected all the way to here. And this one, let me take a new color, let's say this guy here. And this one go here to this resistor. Or maybe let me draw better. This one come here to this one. This one go to the ground. And we take one signal from here, go to this guy. Yep, this one nice. Okay. So now what we can do is, first we desolder this resistor, we don't need it. We desolder all these 4 resistors, we don't need it. Plus we need to isolate the output of this op amp from the run pin so we can force it to be run. So we need to cut this trace. Okay, this is the third. So this is first, second, third, cut the trace. And also you notice here we have on off button. Okay, from the on off button I have noticed, and I check already, this pin or this bed is being already connected internally from the back side. Okay, is been already connected internally to where? To pin number 8, which is very useful. So from here we can just take this pin to 5 volt, which is happen to be here. This is a 5 volt regulator. This is a 5 volt regulator. So we just need to take this pin and connect it to the output of the 5 volt. Then voila, we force the LTC to be always running without under voltage protection circuit rubbish. Okay, so this is what we want to do. Again, desolder this put, desolder all these 4 capacitors, cut this trace and short this pad to the 5 volts. Okay, let's do it. Yeah, I already desoldered the under voltage potentiometer, and also I cut the trace here as I discussed with you previously, and also I join the pin number 8 of the LTC to the 5 volt to force the LTC to be always on. Okay, and the rest of the resistors here should be also taken out, but I didn't desolder out because it's too narrow, the space here is too narrow. I can't desolder it, and unless I need to desolder this voltage control resistor, which I will do later. Okay, so I tested out, everything is okay already. So now I will work on the current limit circuits. Okay, let's continue.
Guys, after we finish with the under voltage circuit that we talked about previously, so now we will talk about the constant current circuit. It consists of this potentiometer, which is 200K, and also half of this op-amp. Okay, so let's see the circuit of this, the schematics of this circuit. Here it is. Let me zoom out. Okay, should be, yep, like this. So this is ground, yeah, that's all. So let me try to do it. Okay, so here is the 200K boot, okay, that's used for constant current limitations, okay, with this half of the LM385. And also this circuit goes to the voltage control of the LTC. Okay, so if you can see here is a comparator again. We have the VREF here that's taking from the current shunt resistor, where it represented by R8, that's got to pin number 3, or the positive input of the op-amp, and also the and compared to the signal from the boot here, okay, that's go to the negative part of the op-amp. So what we need to do is first we take out this resistor, this resistor, capacitor, and also we take out this diode. Okay, so this will disconnect all the rest of the circuit from the voltage control circuit. Okay, so what we're gonna do, we take out this 200K, we take out this resistor, okay, which is 1K. Is it 1K or 100K? Let me check the schematics. Yes, 1K, this one R6. And also we take out this guy here and this capacitor. Okay, this one also will be taken out, and this is the diode that we talk about. Also, we're going to take it. Okay, so now we need to take out 1, 2, 3, 4, 5 components. We need to desolder them to disconnect and isolate the current, constant current circuit.
Okay guys, so as you can see here, I already desoldered all the needed components as we discussed previously. This is the current constant current circuit. It's been desoldered and all the components related to it. And the voltage control, I extended using these 2 wires to here. Okay, so I can control it externally. And here you can see I already power up and nothing is broken, and it's outputting 9 volts, 9.6 volts. Okay, so far I clear up all the components that we don't need it so far, so we can proceed from here.
Well guys, I don't want to make the video too long for you, so I prefer to release this video first as part 1. Okay, so to conclude this video, we have removed the under voltage potentiometer and the related components, and also force it to be always run by short this pin, which is the run pin. Then we have desoldered the current limit potentiometer with the related circuits as well. And at the end, we have desoldered, it's not desoldered actually, we just move out the voltage control potentiometer out of the board, so we can easily access and modify the board. Okay, so with this video, I believe it's long enough to be released as a video. So stay tuned for the part 2, where we will try to inject external voltage using PWM or digital potentiometer, okay, to change the output using the MCU. Okay guys, so I hope you have learned something from this tutorial, how to prepare the DC-DC module for the next future tutorial. Stay tuned for that.